Hello everyone, welcome back to this Siemens SINAMICS S210 server drive and motion control series video. And in this video, I will show how can we implement the safety function for the server drive SINAMICS S210 for STO and SS1 function. And I will use the safety controller CPU 1511 TF, this technology controller, and F safety built-in controller. And I will use the eStop button and the gate switch, these two different input to connect to the STO and SS1 function to control the SINAMICS S210. This is server drive. Okay, let's start. So this is the demo I'm using. In this demo, I have this 1511 TF controller, and I have one 1500 this is safety input card. And this safety input card, it has two inputs. One come from this mushroom, this eStop button, and one come from this gate switch. On the right side, I have two server drive right here, and I will use perfect safe, the communication way, to implement the STO and SS1 function. Okay, so firstly, I will configure the safety card, and this safety card we will read from this eStop and the gate switch. Okay, let's go. At the right side, I will find the safety module. Go to the digital input and find this safety card, 16 channel. And this module, that's the 526 1BH00. Okay, I will drag to here. After I drag it to here, we will see this card image this address from 0 to 8. It includes 9 bytes behind. That's because for the safety card, rather than the standard signal, it also need to communicate with the controller to exchange the status of the safety inputs and outputs. It's actual input that includes 16 input that come from the 0.0 to 0.7 and 1.0 to 1.7. 16 inputs. Okay, then let's configure this card. So to configure this card, we really need the hardware wiring way. So we need to understand the safety circuit. I will briefly introduce this. In this system, I have the eStop and the gate switch. The eStop, this wiring, the test signal come from this US0, okay? And it go to the eStop. And then the signal from the eStop, one channel, it go to this number 2, this pin, DI0. And another input go to this DI0 at channel 8, 22. That's why you will see this blue and this dark gray. Okay? So this is eStop, the signal come back from the eStop button, but the test signal come from this US0. This is the test signal. This is the eStop. And then for the gate switch internally, it also runs similar as eStop. The gate switch used in this demo, it does not supply the OSSD function. It just runs as a single switch. So the test signal that come from connect to this 11. Then the 11 as a test signal source. When the signal come back, it has two channels. One go to the CH4, one go to the CH12. So the channel 4 and the 12 used as a one group. But the test source come from the US1, the test 1. Okay. eStop, the test source come from the US0, but the channel, the CH0 and the CH8 used as one group. So keep in mind this. Okay. Now let's go back to the configuration. So let's double click this card. Let's go to the properties of this safety. So let's firstly look at this channel here. For the input, it has 4 sensor supply. The 4 sensor supply that represent this 4, 1, 21, 11, and 31. And then let's look at this properties. Sensor supply 0. Okay, the sensor supply 0, that serve for the channel from 0 to 3. Okay, so this is a short circuit. We can activate that. The pin 1 at the terminal, that will supply the power. Okay. Then for the second one, the sensor supply 1, the supply 1 supply the channel from 4 to 7. So we activate that because we will use the 4 and the 21. Okay, so we activate this. But for the sensor supply 2 and 3, we can deactivate them. Okay, we deactivate them because we are now using them. We are only using the supply 0, that's the pin 1, and the sensor supply 1, that's the pin 11. Okay, then let's go to the channel. So the first group channel 0 to 8, channel 0 to 8. So we can see the channel 0 to 8 that both come from the e-stop button, but come from two channels, two individual channels. So to compare these two individual channels, this is a common way using the e-stop, receive the e-stop signal. We will use 1002, so equivalent. Okay, they are the same, equivalent. And the discrepancy behavior, then we can supply 0, this is the common way. And we can increase the time if some cases the two channels from one e-stop button, that two channels cannot react exactly the same. It has a slightly discrepancy there. And this reintegrate after the discrepancy error. So usually we leave as test 0 signal, not necessary. If in the system is very super important, depends on the CO level. Some cases you need to select this. You can leave the mouse here and you can read the help for this explanation. Okay. And for the individual channel, we can see we active this 0 and 8 channel. Okay. And the input delay, that's 3.2 to get rid of some noise. For the channel 4 and the 12 is connecting with the gate switch. They are not OSSD signal. We can see the channel 4 and the 12. We join the two channels together, 1002. And we can leave this supply value 0, 50 milliseconds for the discrepancy time. And this test is a test 0, not necessary. Okay, same thing for this. Okay, this is the channel 4 and the 12. Okay, and for other channels, we can disable them. Okay, so we can go to the channel 1 and the 9, disable those channels, the one we are now using. Okay, channel 1 and the 9, disable. 2, okay. Channel 2 and the channel 10. Channel 3 and the 11, we can disable them. Channel 5 and channel 13, disable them. Channel 6 and 14. And the channel 7 and 15, we are now using them. Okay, so again, we only use the 0, 8 and the 4, 12. Okay, and after we configure this, let's go to the F parameters. So the F parameters, there's one important address. So here, this address, this is the one safety address assigned by the system. And we can see this behavior after the channel fault, we can passive the channel. Okay, to passive the entire module or passive the channel. Usually we will select the passive channel. Okay, and you reintegrate, we will leave this default, all channels manually reintegrate. We will program one function block, reintegrate function block to manually acknowledge the safety, especially after we cycle power. So we can use one button to acknowledge this safety reintegration. Okay, so we double check this F address here. After we configure this and download while we are online, and don't forget we need to right click this module and click this assign profit safe address. That means we will assign this address to the card. Okay, we can leave this address here. Now we can save and compile. So temporarily compile to see if there's something wrong from this safety card configuration. As we can see, it definitely needs time to compile. After it compile, we will see the system automatically generates this safety administration. Okay, that's because before the CPU basically run as a standard CPU. Once it has this safety card here, then the CPU will automatically assign all the sub-function blocks serve for the safety. And also, if we double click the safety, this properties, and go to this ProSafe, and we will see the safety, this F activation is enabled. Then all those things will automatically assigned. Okay, automatically assigned. Okay, we finished the compile. Now let's go to the drive. Double click this drive station. Click this profit night and click the properties. In the previous video, I showed how can we add this Telegram 750 for the torque. Then to add the safety function, we still need to add the telegram for the drive. So at here, we can double click and we'll see add safety integrate telegram. So basically, this is standard safety telegram that includes a lot of safety function already. So we can click this. Most of cases, this standard safety telegram that's enough. And this telegram number, this is 30. It includes 6 byte input and 6 bytes output. And we can look at the right side here. So this is the system, the safety input and output. Okay, it starts from the 302. Okay, and then let's go to the blue drive. Click this, and the blue drive here I can add the safety. So the blue drive I didn't add the torque value, so which doesn't matter. So we can add this safety integrate telegram 30, and we will see the system assign the 308. Okay, input and output 6 bytes. All right, we add to here, and then let's go back to the safety here. And currently, the standard program and the safety program, they come together. So personally, I will recommend we can create 2 folders. So we can create the add new group. We can call that is the motion control. Okay, we can drag all the motion control to this folder. And I will create another folder and name the safety, the all safety program, drag to here. Okay, and basically this FB1 run the role as the main program for the safety program. If we double click this CPU safety administration, we can see, so the safety organization block, that is this 123, this 123. And 123 automatically call the FB1. And the DB1, this is the safety DB. And all those things automatically assigned by the system. Okay? And you do not need to specially call this FB1. All the safety program, you can just directly go into this FB1 and start here to program. And the default, the FB1, that's the FBD language style. So we can go to the properties of this FB1 and change the FB and change the FBD to ladder logic. Okay, and click OK. Then we'll see the FB1 that is the ladder logic style. Okay, now basically we finish the hardware configuration. So let's firstly download this controller, and we need to assign the safety address for the safety card. Okay, compile and let's download. Let's download and let's start. All right, after this, let's go to the hardware again. Then let's find this safety card. Right click, click this assign ProSafe address. Okay, so we will see. We can click this identification. Because I tested this card already, so it assigned this address already. If this is the first time, then you can click this identification and find the card is supposed to be, and click this confirm and click this assign. Keep in mind, you need to assign this. Okay, and after we assign this, then we need to go to the drive and also active the drive STO and SS1 function. Let's go to the drive. Okay, let's firstly go to the drive read. Double click this parameter and go to the safety integrate. So now I'm using the Startdrive. Actually, you can also go to your web browser to web browse your drive, this SINAMICS S210, and then you can use the web browser to activate the safety. They are working as the same way. Okay, so here I will use this Startdrive to configure this write motor, and I will use the web browser to configure this blue. Okay, here let's double click this parameterization and go to this safety integrate and click here, and then let's click this go online. While we're working at this Startdrive, for the safety integrate this configuration, we are online config this drive. So now we can click this edit. Okay, click this edit So default, the safety is disabled. So let's go here, click this basic functions. We will firstly implement the STO and SS1. So STO and SS1, they belong to the basic function. They do not need any additional license. So this is the built-in function. We just need to enable that basic function. Okay. And we are the perfectly safe. So if you are using the board terminal, so as I introduced from the drive, it has 2 channels safety input. So you can use the onboard terminals. But in this case, I'm using the safety controller, this F controller, and so I'm using this perfect safe and the STO and S1. So now we can click this button to jump to the configuration. As we can see from this chart, the key difference between the STO and SS1, that is, so for the STO is very easy to understand. Safety torque off. So once the safety signal command from on to off, basically that means we press the e-stop or we open the gate, then the torque will be off. But while the torque is off, the drive will running as a coast to run down by the free run by itself. But for the most application, we do not want this. We want the safety immediately stop. So that means the system will control the motor to stop as quick as possible. Then this feature that belongs to the SS1. For the SS1, it running as is. Firstly, in a short moment, the system will firstly stop the motor as quickly as possible, and then it will switch to the STO, shut off the torque. So as we can see, this control the speed going down, this will be a short moment. So once we go to the STO here, we will see there's one setting. This setting basically means so how long we will assign the time to do the immediate stop. So for example, we can do the 0.5 second for the immediate stop. This 0.5 seconds work for the SS1. After the SS1, then it will do the STO function, torque off. Okay, usually we will leave a short period, basically half second or 1 second, depends on moment of inertia of your load. If your load very strong, then you probably need a longer time. If your load very light, you can set even 0.1 or 0.2 seconds. Again, the time basically for the SS1 to immediately stop. After this time, it will apply the STO to the safety torque off. Okay? Okay, we can see this selection. We usually leave at 0, SS1 with off 3, immediate stop. Okay, go back to here. So actually, once you click this STO or this, they both go to this option. So no difference. All right, then let's go to the control, quickly review. This means if the communication fail, so what should be for the drive? It should do the STO or do the SS1. Okay, some cases if the communication dropped, the drive should immediately stop. Otherwise, that means totally lose control, right? So I personally will recommend that we can do the SS1 to make sure if the communication drop, the drive should immediately do the SS1, do the immediate stop. Okay. Then there's one address you need to be very carefully is this perfect safe address. So default, that's the 0. And it comes from the P9610. Okay, you better write down P9610. This is perfect safe address. So where this perfect safe address come from? So if we click this button, Telegram configuration, it actually jump to the hardware configuration when we configure this Telegram 30. And under here, if we click this send and receive with this red yellow mark here, so we will see the system assign this IP address for the right motor, that is 1. Okay, so ideally this perfect safe address should be 1. Okay, I will download this station after to make sure this 1 right into the drive, or we can manually change this P address into the drive. Okay, so this red motor, okay, this red motor need to be 1. So we could go to the parameter wheel, find out P9610. P9610, this address. Okay, this is the right drive, so we can change this 9610, this safety address to 1. Okay, so we online change this, and then once we come back to here, we will see this perfect safe address will change to 1. Now we'll find the telegram on the top is still showing the 0. So we need to change this telegram to 30 also. So let's go to the parameter and let's find the 9611. So let's change the telegram to 30. But by default, we can now directly change the P9611. We have to go to the P10 at first to change that P10 to 95 to allow the safety commissioning mode to be on, active. So let's go to the P10 at first and change the P10 to 95, and then go back to P9611 and change this telegram to 30. After we finish this P9610 and 9611, then once we come back, we'll see this online will change to the telegram 30 and address change to 1. The test stop, this is the time, is a counter behind to check. During this time, there's no any safety stop happens. After the time expire, it will ask you to force you to do the one safety test to test this safety is still working properly. This is basically a safety standard behind. So basically you can leave a couple weeks or a 1 year, need a one time to test. This depends on your application required. Okay, so 9,000 hours at here for the test stop. Password. So some cases the drive will force you to type in the password, and personally I also recommend you better write down the password and set the password to here. So I can change here 1 2 3 6 7 8 and repeat 1 2 3 4 5 6 7 8. Again, I'm online and I enable this edit. So everything I'm operating here that directly read into the drive. Okay, I change the password and then let's go to the function. Okay, at this function status, we can online monitor the safety status. Currently, we haven't programmed yet. There's no any safety enabled. That's why STO active that stopped. So we need to program the logic. And in case you are using the safety terminal to implement the safety, so you can change the parameter at here. But here I'm using the perfect safe. And keep in mind, if you are going to use the terminal, then you can select this well onboard terminals. But now I'm selecting this perfect safe. Okay, after we finish everything, we can close stop processing. Okay, and then click this save RAM to ROM to make sure all those settings saved into the drive. Alright, we just finished the drive write. Then for the drive blue, I'm going to use the Webpage to configure this, and then we can upload. So we can use the IE browser. So we'll see we can browse the drive blue. The IP address is 0.11, so we can browse 0.11. Okay, let's browse the IP address of this blue drive, and then let's log in. Administrator. Log in. Okay, we log in into this blue drive, and then let's go to the safety integrated, and let's go to the commissioning. Okay, and then let's select this basic function. Basic function, the STO and SS1 all default selected once we enable this basic function. And we are going through this perfect safe. Okay, and then we can assign a password. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. Assign the password. Okay, and then let's go to the parameterization. Click this start. Okay, and this is the time difference. So we set 0.5 for the right drive. So we can also set here. Keep in mind the unit, this is the second. So we can set 0.5 second. So here, that's actually clearer than the start drive. We can see the 0.5 this time is leave for the SS1 to stop the drive. And after this, then it will run the STO. Okay? This is the parameterization. Okay, 0.5 we set here. And then let's go to the control. Click this continue. Select this safety telegram 30. And from here, we can directly set the perfect safe address. So 2, where this 2 come from? If we go back to the program, and this is the drive blue, okay, perfect net port, and go to this telegram, the safety telegram, this is 30. And the safety telegram send and receive, we can see the drive side, the address, safety address, that's the 2. So we can assign 2. Go back to here, the safety address, we leave 2 at here. And same thing, for the perfect safe fail response, we can switch to the SS1. This used to immediately stop the drive if the communication got failed. Okay, then let's call continue. And this is the test stop. So we can leave the time, basically the maximum time, okay, for the test. This is the test stop. Then let's call continue. Basically finish everything. And here the system will pop up this, save all the parameter. That means copy RAM to ROM. Let's click this finish. This is using the web page to configure the safety. Okay. Here, compared with the red drive and the blue drive, I would recommend using the web page to configure the safety for the SINAMICS S210 drive. You will see the web page will provide more information. It's user-friendly. Alright, we finished the configuration. Then let's go back to the TIA portal. At the TIA portal side, we can right-click. At the blue drive, we can click this upload from the device to upload all the configuration to this TIA portal start drive project. Okay, I will click here, click this upload from device. Okay, same thing, I will also do the right drive upload. Alright, so now if I go to the safety, the parameterization from this blue drive, and if I go online, I can online monitor if all the parameter showing here is the same as the web page we just did. So we can go online and go to the control, and we can see the perfect safe address that changed to 2 already. And that's just one configuration. And all the configuration is the same as we did in the web page because we uploaded all the parameters. The 0.5 we set from the web page. Okay, this is the blue drive. Okay. And also because we uploaded the parameter, now if I shift to offline, both offline, from the right drive, if I go to the parameterization, if I go to this offline status, go to this configuration, we will see all those configuration status. They are matching with online we set. Okay, where the perfect safe. Okay, and the STO time 0.5. Okay. Okay, now basically we finish all the hardware safety configuration. We finish the PLC, the safety hardware configuration, and the safety address setting. And also we finish the start drive, this set the STO and the SS1, this basic function. So the basic safety function. Then let's shift to the safety program to control the STO and the SS1 command. To show the safety program, I would highly recommend you go to Siemens support website. Let's browse one application from the support.industry.siemens.com, and you can search this ID 1094-85794. Okay, this ID number. And you will see this is the one library to implement the Siemens drive safety. Okay, and basically using the Telegram 30, and it provides us the status and the control command. Okay, so let's download the menu and let's download this library. And I will show how can we use this library. Okay, go back to our program. I copy this download library into this directory, and I will call this library. Keep in mind this is a library, so from the project, from right side here, so I will click this Open Global Library. Okay, let's go to find out this library directory and find out here, and we will see this full name. Okay, we will see this library that based on the TI Portal version 16. Now we are using version 17. Okay, click open. It will automatically upgrade to version 17. We are opening the TI Portal version 16 library version. So let's click this upgrade. Okay, we import this library. And then let's open this library. And we will see this library based on the controller we are using. We could use the i7-1200F or 1500F. So we'll use the 1500F. And go to the general and go to the perfect save control. It has control word, telegram 30, and status word, telegram 30. Okay, again, so the block we will use under the 1500F, and we will use the telegram 30 control word and the status word telegram 30. Okay, then we need to copy. So firstly, let's go to the function block here. So at here, we will program something. So open the library and let's drag the control command. The control command, look at this word. This is the for S. S means the SINAMICS S series server drive controller. For control, we will use this function block. Drag to here. The first one, it can based on the write drive. Okay, this is used to control the write drive. Click OK. Okay, and this is the control. Then for the status, we can go to, again, go to the S, this SINAMICS S status. Let's drag to here. In the meantime, we will see the system automatically copy this instant FB to here. Okay, and then this status that's also based on the write drive. Write drive. Okay, and we can write something here. This is the write drive safety control. And this network 2, that's the write drive safety status. Okay, and other than the control and the status function block, we also need this UDT, this structure. That's because for the status input here, it needs this UDT structure. Okay, we can see it needs this status UDT structure. And for the control, the right side here, the control, that need to connect to the queue address. So that need this telegram 30 control, this control that UDT. So we need to copy this UDT to our project. So the PLC data type here. And we can drag this control UDT to here, PLC data type. Okay, and this status, keep in mind, we need to drag the correct one. Okay, we drag this S here, and S telegram 30. Okay, drag to here. Under this PLC data type. Okay, then we can go to the variable list, the PLC tag. Show all tags. We need to assign the input and output of the safety. We need to assign the safety input and output based on this data type. Okay, we can follow this. And let's quickly review the safety hardware. So safety hardware, we need to find, double click the PerfectNet port, and go to find here. So for the write drive, if you recall, the send and the receive the safety, the telegram 30, their starting address that start from the 302. Queue also start from the 302. Then when we claim the input and output for the write drive, so we need to call this. Okay, this is the safety. We can name that SF drive read. Okay, safety. And this is the status. The status and the date type we just drag here. That's status. Okay, status. For the control, SF write drive write control safety. And the date type we need to select. That is a control this date type. Okay, this control date type. Okay, select this. And when we select this, we need to change here, this automatically assign here. So the status need to come from the input 302. Okay, input 302, change to here, input. And the control, I need to control the Q302, Q302. Okay, so this is for the write drive. Then let's shift to the blue drive. Okay, double click. So we'll see for the blue drive, it starts from the 308. I'll flow here. So for the blue drive, SF drive blue status. So that based on the status, right? Status date type. And the status, that's the input. So this input should be the I, but starting address, that is 308. Okay, and then the SF underscore drive blue control. So this date type based on the control date type, then that should be the Q308. Q308. Okay, this comes from the Siemens, this standard. Okay, this structure. All right, after we configure this, then when we go back to the program, I'm still temporarily float this here. When we go back to the program, all right. So for this function block control, the output should be the Q address for the write drive. So the Q for the write drive control. So this is the Q302. So we will drag to here, release. Okay, and for the status here, that is here. So the status of the read, this is the input. So here, drag to here. Okay, this is for the write drive. Then let's program for the blue drive. For the blue drive, we will call the blue drive control to here, drag to here, automatically assign. So change this blue drive. Blue drive control. This is the blue drive safety control. And again, this blue drive safety control, the control, that's the Q address. So we'll drag this blue drive control to here. Okay, and then the network 3. Then the network 3, I will drag this status, drag to here. And automatically assign this DB number, change this to blue drive. Okay. And this input, that should be the blue drive status input. Okay, drag to here. All right, we can change this network 4 to blue drive safety status. Okay, and other than this, we also need to program one system integrated to acknowledge the fault. Okay, let's go to the right side library. So let's go to the instruction. Let's find out the acknowledge. Okay, acknowledge. Drag this acknowledge. Okay, acknowledge. So this acknowledge is used to integrate the system after the cycle power or anytime if the safety has something wrong. so we can acknowledge the safety fault. Okay, and this acknowledge can be connected to one HMI button, so we can claim 1 dB. So this dB we can name as the standard dB, but this standard dB, this is the dB for PLC and the safety, and this is standard dB. Okay, and in this standard dB we can flow that, and first one, this is the safety acknowledge push button. Okay, drag to here. Okay, this is the system level, the acknowledge push button, ACK. Okay, then let's program the eStop function block. For example, the eStop function block, eStop, drag to here, and eStop dB. So we can name this eStop is a real eStop, so we can name that eStop dB. Okay, and this eStop input that come from our digital channel input 0.0, because the 0.0 that receiving the eStop button signal. Okay, so we can name this input, this is the real eStop signal, and this is the real eStop signal. eStop push button. Here, the acknowledge necessary that equal to true. That means after we press eStop and after release, so we need one acknowledge signal to acknowledge, then the output will change to 1. That's 99.9 chance we need to leave this true and need to acknowledge. Otherwise, once the eStop button got released, then the eStop, this queue will be on directly. This is dangerous. So we need one acknowledge signal. And keep in mind, this acknowledge signal usually is not the same as this acknowledge, because this is a safety acknowledge to acknowledge the entire system to reintegrate. But this acknowledge usually is used to acknowledge the channel or acknowledge the function-wise the acknowledge. So I can call this is a reset signal. Okay, safety reset push button. Okay, so this safety reset we can drag to here. And the time delay, we can delay a little bit of time. This is the milliseconds unit. 50 milliseconds. Okay, leave to here. And the queue of this eStop function block can be used as any other control-wise the command for them. So we can use the queue output. Then we can create one safety dB. Okay, so we can create a dB here, add block under this folder safety, and we can click this data block. This time we can check this create safety data dB. Okay, and this safety data dB we can name that, we can name SF dB. Okay, and the variables acknowledge, and here we can name this as the eStop button queue. And the second, we can name that gate switch queue. Okay, let's leave here. And we can drag this eStop button queue to here. Okay, this is the eStop. And then let's program the gate switch. The gate switch is a function does not supply the OSSD function, so it only run like a switch, similar like a eStop. So we can still drag this eStop function. And the instant name, we can name that this is the gate switch. So we can click OK. And the gate switch, we can use the input 0.4. Okay. And then we can rename this as a gate switch. Okay, rename that as a gate switch. And to show the difference between this acknowledge necessary or not necessary, I will leave this acknowledge necessary as the false. And we will see as long as we close the gate, then the output will be on without this acknowledge needed. Okay, So the time delay we can leave as a 0 or set very short, t upon 10 milliseconds. Okay. And the Q, we can drag this safety dB, this Q, and give the output here. Then those two Q can be used as a command. Then let's go back to the safety function block. Okay, so for the STO and the SS1, for the STO, definitely we need, as long as the E-stop pressed, then we need to do the STO, right? So we can do the E-stop, and if the gate, same thing, if the gate opened, we also need to do the STO. And for the SS1, we only need the E-stop, right? If the E-stop on, as long as E-stop on, we do not need to execute the SS1. But if we door opened, then we need to do the STO, the safety torque off. Okay. Same thing for the blue drive. So for the gate switch and for the E-stop. And for the SS1, we only need the E-stop. And for the SS1, we need the E-stop. Okay. Okay, so we execute this. And we will see here, there's one acknowledge safety fault. So we could drag that acknowledge button, the reset the signal to here. So we can drag to this to here, acknowledge. So reset. Okay. And from the output, we will see the output. Without any connection here, we can still see the status. So in the real case, we can program some safety output status, drag to here. We will see if the E-stop pressed or gate opened, so STO active or SS1 active, then the output will be on. On means the system is at safety mode. Safety stop the machine. So we can show on the HMI with a yellow or with a red indicator when this active turns on. So now we can download the safety program. Before that, all our commands are below the control command. This is not quite good. So I will reorganize this sequence. So I will close all the network and drag the number 1 to number 4 to the bottom. Okay. Okay. So acknowledge, E-stop, gateway. These are the command reading the signal input, and those function blocks are used to control the safety to the drive. Okay, now we can download all the safety program. All right, now let's download this entire project. Compile and download. Okay, let's download. Okay, download the safety, we need to stop the CPU. Okay, let's stop. And let's start the controller. Okay, after we download the CPU and download the Startdrive, or basically configure the STO and the SS1 from the drive side, I recommend you cycle power the entire system, or at least cycle power the drive. So let the system cycle power and restart again. Okay, after the system boot up, we will see the drive, right side two drives shows green, but the controller shows error. But don't worry, that's because after the system power up, we haven't acknowledged the safety yet. So we need to go to the program IP1, and we can acknowledge the fault. Basically reintegrate the fault. So we will see both signal goes off because we haven't acknowledged the safety yet. So we need to acknowledge. Once we acknowledge, then the error gone. So keep in mind, in the safety program, you need to use this acknowledge global to acknowledge the fault. And then also for the each e-stop channel or gate switch channel, if some channel need the acknowledge, so like here, so even the e-stop signal on, but this is the channel need the acknowledge necessary. So it's waiting for us to acknowledge this. So usually this one can be left on the HMI, so we can acknowledge on the HMI. This usually comes from the physical button to acknowledge the safety fault, basically used for the maintenance wise. Okay, so we will see this is called reset, this is called acknowledge, safety acknowledge. Okay, so this one I can acknowledge. So once I acknowledge this channel, we will see the queue will be on. Then the gate switch and here, okay, the gate is opened. If I close the gate, we will also see the gate will be on. Okay, I will close the gate. Okay, so now all the safety okay. And when the safety shows okay, the output here that shows off. So basically when they on, we can show a red indicator shows error on the SS1 or STO to show the safety is now at OK status. Okay. At this moment, if you see any fault from the drive, you can try to go to the drive and open the online diagnostic, and you can see the active alarm to see. Sometimes at the early beginning, the first time, the drive want to have a STO at on status. It basically is asking you, so what the status should be the correct. So definitely the on for the STO should be the correct status. Then we can acknowledge the fault. For example, in this system, I had this acceptance test and the STO, this initiate required before. So after I turn the STO signal on, so and the cycle power, then the system feel okay. Okay, now all the safety shows okay. I can turn on the drive. Okay, I can go to the power on the right drive and power on the drive. Okay, I can power on. And now I can spin the motor. Okay, no any error. And I can fire the motor. Okay, it is moving. And now if I press the E-stop, so we can monitor the safety program. Okay, let's look at this right drive safety output here. Okay, if I press E-stop, alright, we will see the STO, SS1, they all on. On means, okay, it's not okay. The STO or SS1, the STO and the SS1, the active, the safety stop. Okay, and let me release. So after release, we haven't acknowledged yet, so the system still shows at the stop status. So let me acknowledge. So let's acknowledge. Okay, after acknowledge, we will see the system go back to the normal status. Now, let me go to the program again. Now, let's power up again. Okay, I need to reset the drive, reset this axis because we hit the E-stop. Okay, reset and the power on again. Okay, we power on again. And now let's fire the drive with a faster speed. Okay, so I'm gonna set very fast. 10 times. Okay, and let's fire. Okay, now the drive running very fast. The reason why I'm running very fast because I'm going to open the gate, and because this is the STO, so open the gate will only fire the STO, so we will see it will coast run down. So if I go to the safety, and we will see the gate switch once it's off, it will fire the STO only. The e-stop will still be on. So once the STO go off, so we will see the STO will be active. Then the drive will slow down, will ramp down. Okay, now I will open the gate. Open. You will see in a short moment the drive still moving. It's not immediately stopped. Okay, while the door is open, we will see the STO true, but the SS1 is still okay. So let's close. So once we close, if you recall, the gate switch does not need the acknowledge. Then as long as the signal go on, then the STO is okay. Okay, now let's fire it again. Fire the STO now. So this time I will turn on the light to make this clear. Let me fire up the drive again. So this time turn off. So click this reset. Access need to be reset. Okay, then let's power on the access. Now then let's go down to fire it up. Okay, the drive now is running, and if I hit the e-stop, then we'll see the drive will stop very quickly. Hit, but stop. Okay, release. Go to the safety, acknowledge this e-stop. Acknowledge this e-stop. Okay, we need to acknowledge. Okay, e-stop returned. And let's test again. So let's go to the access control. Reset the arrow for the access. Then power on again. Then power on again. And then let's go to the velocity. Velocity, let's fire the velocity again. Okay, now it's running. Go back to the safety. And let's watch this status. Okay, this time I will open the gate again. So once I open the gate, I can see in a short period the drive coasts down. Okay, so let's do again. Close the gate, return, and click the reset. And here, go back to the program. Reset the access. Power up again. And this time we can run faster. For example, I can set this command to 7500. Okay, and I can trigger. Okay, we run very fast. Now if I open the gate, we will see it coasts down. And this time we will see, once I open the gate, it needs a short period to totally stop. 1, 2, 3, open. So we will see it roughly needs 1 more second to totally stop. Okay, so this is the STO and the SS1. And this is very important to implement this function into this drive system. And I had one issue that at the early beginning, the system asked me to do the acceptance test and STO. I tried around 10 minutes to figure out. Eventually, I found as long as at the safety, at the early beginning, I make the system on, and then I can acknowledge the fault at the drive side, then all those issues got solved. This is some experience I like to share at here. So at the early beginning, the first time when you implement the safety STO and SS1, it won't be super smoothly. Somehow you need to acknowledge at the drive side first, and then go back to the controller, and then go back to again, back and forth a couple of times. And keep in mind, every time you change the safety parameter, and don't forget, click this copy ramp to ROM, and the cycle power after that to implement the safety, to enable safety totally. Okay, this is the SINAMICS Drive S210, the safety control, STO and SS1. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.